All right. So next we'll do price elasticity of supply, which has the same formula. It's a similar concept. What you're measuring is how responsive the seller is when the price changes. That didn't work. So when the price goes up, we know they want to sell more, but how much more? So how elastic their supply is going to tell us how much the quantity will change. There we go. Okay, so the formula is the same, though, as with demand. Percent change in the quantity over the percent change in the price. And then we will classify it exactly the same way as well. If it's more than 1, it's elastic, less than 1, inelastic, equal to 1, unit elastic. All right, so pretty simple, and there's only one type of elasticity for supply, not like demand where we had 3 different types. Okay, so what is the price elasticity of supply when the price changes from 3 to 4? So the quantity increases from 550 to 600. Okay, so we'll do the calculation. This will be the Q2 and P2, Q1, P1. So that's less than 1. So that supplier would be inelastic. Now, what would make your supply elastic or inelastic? So in other words, what would be the difference between a situation where you could change the quantity by a lot or only change it by a little bit? So if the price goes up, you would want to make more of the good because you're going to make more profit if the price goes up. But if you want to make more of the good, then you have to get the inputs to make the good. Now, some suppliers might already have the inputs on hand, like if it's just something that you've got in your storeroom, you can just bring it out and use it. Or if you've got the workers already and they're just maybe not working very many hours right now and they're quite willing to increase their hours. You know, in that kind of a situation, it would be easy for you to increase your production. Or if you could get the inputs easily. So if you're making something simple like pizza, right, you can get all the ingredients at the grocery store. But if you're making something that's more complicated, where you need some type of ingredient or input that has to be imported from another country, you're not going to be able to get it by tomorrow, right? It's going to take you some time. And so then you won't be able to increase your production right away. You'd have to wait. All right, so what determines elasticity for suppliers? So first one is the availability of inputs. So if it's easy to get, or if it's difficult to get the inputs, then you won't be able to increase your production right away. So you'd have more inelastic supply, or the opposite. And then related to that would be how much capital do you have available? So if your production requires building space or some type of major equipment, do you have that already, or would you need to get it? So if you are, say, making pizzas, and let's say you have a pizza factory, and you've already got the building. Let's say right now, though, you're only making pizzas from 9 to 5, 9 in the morning to 5 in the afternoon, and then you want to increase your pizza production. Well, you just hire more people and have them work, an evening shift, and so that would be fairly easy for you to do. But if you had the pizza factory and you already had shifts all around the day, like 24 hours a day, and then you wanted to make more pizzas, then you couldn't because you're using all of your capacity already, all of your physical capital. And so then what would you have to do? Well, I guess you could make another factory, but again, that is not easy to do, so it'd take time. Okay, so if a business has idle capacity, that means you've got some physical capital there, but you have a time where it's not being used, then you can easily start using it. So you could increase your production more easily and you'd have more elastic supply. Otherwise, if you're close to full capacity, so you're already using all of your physical capital, then you won't be able to increase your production very much. So then the last thing is time. So just like with the consumers, when you measure the elasticity, if there's a price change today and you measure the response for tomorrow, you're not going to see much of a change. But if you give the producers more time to find inputs or to find more factory space or more office space or whatever it is that they need, then you're going to be observing a much larger change in the quantity supplied. So the more time you give them to respond, the bigger the elasticity that you'll be able to measure. All right. Now, just like with the demand curve, the elasticity for supply is not the same as the slope, but the slope will tell us what kind of elasticity you'll probably be measuring. If you have a very steep slope, that means you're going to have big price changes and small quantity changes, so you'd have a more inelastic supply. Whereas if you had a more flat slope, then you'd have bigger quantity changes and smaller price changes, so then you'd have more elastic supply. And so then here we're showing the two extremes, which is vertical or horizontal. So perfectly elastic and perfectly inelastic. So perfectly elastic. One example would be something like online music or something else that you can buy online, or like apps that you can buy, like where it's software. Because for the producer, once they've made, say, a song and they've recorded the song, then it's very easy for them to make it available to the consumers. And so they will make the song available to, like millions of people if people wanted it. And so if you are in the business of making music, what you would do is you'd say, okay, at this price, will I cover the cost of making the song? And if yes, I will cover the cost of making the song, I will make the song, and then once it's made, I will supply it to whoever wants it, right? Could be millions of people. Very easy to just keep supplying it at that price. But if the price is too low and you're not going to cover your cost, then you just wouldn't make the song at all to begin with. Okay, perfectly inelastic is a situation where the quantity is fixed. So this would probably be some kind of natural resource where we can't make any more of it, like land. And so especially land on an island, you just can't make any more of it. And so the price can go up and up and up forever, and quantity will not change. Good. Okay, so that's it for supply. All right, so the last part of the chapter is about taxes. All right, So, in particular, what we're going to talk about is who pays the tax and how much deadweight loss is there. Okay, so deadweight loss, when you add the tax, is going to be, actually, you know what? Wait, first, surplus, without a tax. Okay, so without a tax, the surplus at the equilibrium for everybody would be here. Or, no, the lines don't quite go over to the axis for this one. That's okay, we'll just sort of make it up a bit. Okay, but when you add a tax, it's going to raise the price and decrease the quantity. And so then we will have deadweight loss, which will be that triangle and this triangle. Now, there's a big difference here. In this diagram, the two curves, demand and supply, are both relatively elastic because they're flatter. Whereas this diagram, the two curves are relatively inelastic because the curves are steeper. As a result, in this diagram, the quantity change is small. The price goes up, but because the demand is inelastic, the quantity does not decrease very much. So therefore, you don't have very much deadweight loss. Whereas here, the consumers are more price sensitive. So as soon as the price goes up, people buy a lot less. And so as a result, you get a lot more deadweight loss. Okay, so the change in quantity is greatest for a market with elastic demand and supply curves. So then you get more deadweight loss. And now the tax burden or the tax incidence. So that referred to who paid how much of the tax. So the tax would drive a wedge between the consumer price and the producer price, but that could be equally divided between the producers and consumers or unequally divided. And what's going to happen is who pays more of the tax will be whoever is more inelastic. Because whoever is more inelastic will have a steeper curve, and steeper curves result in more significant price changes. Okay, so the tax burden or tax incidence will be paid by whoever, ever is more inelastic. Okay, so first example is milk. That would be a necessity for consumers, and so then demand is more inelastic. So we have it shown as steeper compared to the supply curve. Now, here's the consumer price that they pay with the tax. That is higher than the P star, which was the price that the consumers paid before the tax. And so this area would be the consumer incidence. It's the extra amount that they're paying compared to before the tax. The sellers get paid less, but only a little bit less. So this long, thin rectangle, that would be the producer incidence. Okay, so demand is more inelastic, so consumers will pay more. Okay, the next example is something that's not necessary, purple silk socks. So the demand curve is now relatively flatter. And when the demand curve is relatively flatter, it means consumers are more price sensitive. The price can go up for them but it won't go up as much because the demand curve is flatter. So we can see then in this diagram that the consumer incidence is just a small increase in the price, whereas the producers then, they're the ones who will have to accept a lower price. So when a tax is applied, it's better to be the more elastic one then. So if you have elastic demand, you won't end up paying too much of the tax. All right, so now we're going to go through examples where the curves are either horizontal or vertical, and we'll see what happens. Now, first one, supply is perfectly elastic. All right, so now we add a tax. So the supply curve will be higher by the amount of the tax. And now we can see the new equilibrium would be here. So consumers will pay this price. The quantity will be here. And so we have deadweight loss because the quantity has decreased, so we have missed opportunities. But who's paying the tax? Now, the difference between this line and this line is the tax. Consumers pay this price, PC. The sellers will get that from the consumers, send that much of it to the government, and so the sellers will get the same price as they did before. The sellers will get, or the producers will get, the same price as they did before. So that means that the consumers are the ones who would pay the entire tax incidence here. And the sellers wouldn't because the price does not go down for them. Okay, so just consumers and deadweight loss. Next one is similar. The supply curve is horizontal, so perfectly elastic. Tax is added. Okay, so same thing. We add the tax. And now the new equilibrium is up here. So the quantity will not change. The price will go up for the consumer. Now the consumers have to pay this price, but the quantity will be the same. So this was Q star, and now it will also be QT. So the quantity will not change. And because the quantity does not change, then there's no deadweight loss. And the producers are just as well off as they were before because they will continue to get the same price. And so who pays the higher price? Just the consumers. So this again would be something like, say, online music or the sale of software. If the government were to impose a tax, the price would go up for the consumer, but probably not down at all for the producer. And it's just because the producers are, in this case, super price sensitive, right? They're going to supply the good as long as they get paid that price. And if the price goes down for the producer, they just wouldn't sell the good. So therefore, they will get paid the same price as they did before. All right, so now the opposite, though. If the suppliers have perfectly inelastic supply, okay, now they are the ones who will be worse off. Now this one's a bit tricky though, because when we add a tax, we are shifting up or raising the supply curve by the amount of the tax. But if the supply curve is vertical, can you raise it up? It's vertical, right? So we can't draw another line. We don't have an ST curve. So instead we just have to think about what's going to happen. All right. Now, okay, first of all, let's just add Q star. Okay, so this is the equilibrium price and quantity before the tax. And now the tax is added. So if the seller were to raise the price for the consumer would buy less, right? If the price goes up for the consumer, they will buy less of the good. And the seller does not want that. The seller wants to sell this much. No matter what happens to the price, the seller wants to sell this much. If they raise the price for the consumer, they won't. The only way to sell this much to the consumer is if they keep the price the same for the consumer. So the consumer would have to be charged the same price. Who's going to pay the tax then? Just the seller. So it's just going to suck for the seller because they used to get paid this price. Now they're going to get the price from the consumer and have to send part of it to the government. So however much that is, this minus the tax, however much that is, will lower the price that the seller gets to keep. So we can just draw that anywhere down here. Okay, so we have no deadweight loss because the quantity will not change. The quantity is still QT. And this will be producer incidence then. So the producer will pay that tax. So this, for example, I'm just thinking about, you know how at some stores they'll say, you know, we'll pay the tax, you know, like a sort of a sale thing, they'll say we'll pay the tax. So probably they do that, it'll be like, say, a furniture store where they already have all the furniture in the store and they want to get rid of it. So they've got this fixed quantity of furniture that they want to sell. They can't raise the price if there's a tax. They have to lower the price for themselves. They just have to pay the tax themselves. All right, next one is going to actually be the same result. The only difference between the two graphs is that now the consumers are super price sensitive, and definitely they can't raise the price for the consumers or they would just stop buying the good altogether. So just like in the top graph, the consumer price will have to stay the same. And so this quantity will also stay the same. This quantity was Q star, and now it will also be QT. And then the only difference is that now the seller does not get to keep all of that money. Now they have to send part of it to the government. And so this minus the tax, they get a lower price. And so again, you can just draw that wherever you want. All right, so this will all be producer incidence. And again, no deadweight loss because the quantity has not changed. All right. Oh, no. Is it going to do that? Oh, yeah, this one here. Okay. Okay, just two more. All right, so now we have perfectly inelastic demand with just sort of like a regular supply curve. And so this would be, we're going to add a tax. This would be, for example, a medicine that is necessary for someone to survive, something like EpiPens or insulin. And if the government were to tax it, it's going to be paid by the consumers. All right, so this was the original price and quantity. So let's label the original price and quantity P star, Q star. And then the government adds a tax, and now we've got a new equilibrium here. That will be the price the consumers pay. Quantity is going to be the same. No deadweight loss because the quantity does not change. And the sellers will get paid the same price as they did before because the consumers are paying this price, and then the difference here is the tax. So the seller will get this from the consumer, they give that much to the government, and they get to keep the same price as they did before. So consumers would pay the tax. So that's why governments often do not tax something like EpiPens, because people need them, and the government would know that that would be kind of unfair, the consumers paying the entire tax. Okay, the opposite is if demand is perfectly elastic, and we have sort of a regular supply curve. Okay, add the tax. Okay, now this was the original equilibrium, so let's label that P star, Q star, and now we'll have a new equilibrium over here where the price is the same. So the consumers will pay the same price. They will pay the same price because they are perfectly elastic. If the seller were to try to raise the price at all, they would just stop buying the good altogether. So the seller cannot raise the price at all for the consumer. So they will pay the same price as they did before. The quantity is smaller because the supplier is not getting paid as much, right? The seller, now the consumer gives them the same price, but they have to send this much of it to the government. So here's the price that the consumer pays them. They send this much to the government, so the seller only gets to keep this price here. Okay, so now we have deadweight loss. And we have no consumer incidents. This would all be producer incidents. And I have one example of this to do with gas prices or gas stations. So now some of you guys probably know that there's different taxes on gas, whether you're in the Greater Vancouver Regional District or the Fraser Valley Regional District, right? So like if you go to Abbotsford, for example, then the gas prices are always lower because they have slightly lower taxes. So where I live, I'm right between Maple Ridge and Mission. So Maple Ridge is in the Greater Vancouver Regional District, and Mission's in the Fraser Valley Regional District. And so there's always at least like a 10 cent a liter price difference in gas. And so right on the border where I live, there were gas stations on either side of the border. So you had gas stations that were in Mission that were cheaper, 10 cents a liter at least, cheaper. And then you had one lonely gas station on the Maple Ridge side, as gas was more expensive. And they were only like a kilometer apart on the highway, so it would only take you an extra 2 minutes to go to Mission. So that's what everybody did. And so is this gas station open anymore? No, because nobody would go there. You know, they just couldn't make any money. And that's the kind of situation it was. The consumers there were just not willing to pay the higher price, so they just didn't go there. So what we have here is a calculation question where we've got demand and supply functions and a tax. Okay, so first thing we need to calculate is the equilibrium without the tax, so just using these two functions first. All right, and we'll put those numbers on the graph. Okay, now we'll apply the tax. So the function with the tax, so we add it to the supply function, so 5 plus equals P. Okay, so 25. Okay, and then we'll calculate the new equilibrium. And then we'll need the price that the consumers pay. And then the price that the producers get, we can just subtract the $5 tax. You can use the original supply function, or you can just subtract the $5 from the consumer price. So that would be 76.25. There. Okay, so now we can calculate the tax incidences, which will be here for the consumers, and here for the producers. And we can see already that the producers are going to pay more of the tax because the price has changed more for them compared to the consumers. Okay, so we'll do consumers first. So it's just the price difference for them. So their price is 81.25, and it used to be 80. And then we'll multiply that by the quantity. Okay, and then for the producers, the price was 80. Now they only get 76.25. And yeah, so the producers are paying more of the tax. And so then that is because their supply is more inelastic compared to the demand curve. So the supply curve is a little bit steeper compared to the demand curve. All right, so which market agents are more inelastic? All we do is like to know. You don't have to actually measure elasticity. You just know because they're paying more of the tax. So market agents means producers or consumers. So which are more inelastic? Producers are I'll just put PI, so producer incidence is greater than consumer incidence. And that's it.